Okay, so basically today's flip chart was just a review so that tomorrow when we do the CFA, you're ready. So basically, what two whole numbers would the following square roots fall? So I think one of the PDFs that's on the website is the square root sheet. And so if you look at that sheet, you'll notice that none of these are in the square root column. But you can see which two square roots they're between. So for example, 45 would be between the square root of 36 and the square root of 49. So if we're looking for the two whole numbers that the square root of 45 would be in between, we just find the square root of 36 and the square root of 49. So the square root of 36 is 6, and the square root of 49 is 7. So the square root of the square root of 45 would be somewhere between 6 and 7, okay? So just take a minute, pause the video, and see if you can get 3 through 6. Okay, so these should be the answers. The square root of 95 should be between 9 and 10. The square root of 15 should be between the numbers 3 and 4. The square root of 20 should be between 4 and 5. And the square root of 72 should be between 8 and 9. All right, on this one, you're finding the area and the side length of the square. So just to recap, the area is equal to the side squared, and the side is equal to the square root of the area. So whatever number is underneath the radical sign, that tells you what your area is. And if you have the area and want to know the side, you just take the square root, okay? So if you remember, in order to find the area, what you're going to do is you're going to draw the box all the way around, and then find the area of the big red square, which in this case is 81. And then you're going to find the area of these corner triangles, which remember is base times height divided by 2. And you're going to subtract those 4 out. So this distance here is 3, this distance is 6. Remember, we're counting the spaces between the dots, not the dots themselves. So 3 times 6 is 18, and 18 divided by 2 is 9. So in each one of these corners, there's a triangle with an area of 9. So 9 times 4 is 36. So if we subtract out 36, we get that the area is equal to 45. So if the area is 45, then in order to find the side length, remember we just take the square root of the area. So the side is equal to the square root of the area. So our side would be square root of 45. Okay, on this one, we're just finding the value of each square root. This one should be easy enough. You can just either punch these into your calculator or look on your square root sheet. The square root of 64 is 8. The square root of 81 is 9. The square root of 100 is 10. And the square root of 144 is 12. So what that means is that 8 times 8 is 64. If we square this number, we get this number. We square this number, we get this number. We square this number, we get this number. Square this number, we get this number. Now, it's asking you, how does this relate to area? So remember, this value here, the number underneath the radical sign, these are your areas, okay? And then these values here, these are your side lengths, because they are the square roots of these values up here. All right, so if these are your areas, then what we need to do is we need to figure out what the side length is. So if we know that the side length is equal to the square root of the area, okay, and we know that this is the area, all we have to do is take the square root. So remember, the square root and the radical sign, the radical sign and the exponent cancel each other out, and we just take the square root of 121, which is 11 feet, okay? So take a couple minutes, figure out the other side lengths, and then pause the video, and when you come back, the answers will be ready for you. Okay, so we should have 2 miles for number 6, 15 inches for number 7, and 14 yards for number 8. So remember, these were the areas, and these are your side lengths. Okay, and then on this one, they're just asking for the area of the square on the hypotenuse. So if you remember what we did earlier on that little half sheet of paper, hopefully you were able to do that. if we know that this length here is 3, then in order to find the area of this square here, we just square this. So this is, the area here is 3 squared. And remember, 3 squared doesn't mean 3 times 2. Remember, it's 3 times itself. So 3 times 3. And so 3 times 3 is 9. So the area of this square here is 9. And same thing down here. The area down here is 4 squared. And 4 squared is not 4 times 2, it's 4 times 4. So 4 times 4 is 16. And then in order to find the area of this square here, we take these two areas and add them together. So we would take 16 plus 9, oops, and that's going to give us the area of 25, okay? So the area of this square right here is 25. Now, if we wanted to find the length of this hypotenuse right here, then what we would have to do is take the square root of this in order to find this length right here. And the way that these three squares are related is that a squared plus b squared equals c squared, which is just the Pythagorean theorem. So if we find the area of the square on this leg and the area of the square on this leg, it tells us the area of the square on this leg, which is the hypotenuse. Okay, sorry I'm going through this kind of quick. I need to leave pretty soon today, so I apologize. If we need to find the area of the square, remember that in order to find the area, we take the side and we square it. So if the side length is 17, square root of 17, then in order to find the area, we have to square that. And if you remember, the square root and squaring something, those are inverses of one another. And so what happens is those two cancel each other out. And so the area of this rectangle, or sorry, the area of this square is just 17. And also remember we talked earlier about how the number that's underneath the radical sign tells you what your area is. All right, down here on the red square, it gives you the area and it's asking you for the side length. So remember, in order to find the side length, all you're doing is taking the square root. So the side length here would be the square root of 23. All right, on these you just have to find the hypotenuse. So you can either find the area of each square and add it together and then take the square root, or you can use the Pythagorean theorem. There's more than one way to do it. So if you think about it as the area of the squares being added together and then taking the square root, the area of this, there's 1, 2, 3, 4. So the area of this square is 4 squared, which is 16. And on this one, it's 1, 2, 3, 4, 5, 6. So 6 squared is 36. And so then for the area of this one, we take those two and we add them together, which is 52. Okay, so this number here tells us the area of this square. And in order to find the side length, remember, all we have to do is just take the square root of that number. So the length of the hypotenuse here would be 52. All right, so go ahead and pause for a minute or two, see if you can figure out the hypotenuse of this. First, let me show you the other way. You can use a squared plus b squared equals c squared. So remember, if this is a and this is b, we just plug those in. So 4 squared plus 6 squared is equal to c squared. So 4 squared is 16, 6 squared is 36, and this side, remember, stays c squared. So when we add these two together, we get 52 is equal to c squared. And then the last step of the Pythagorean theorem every single time is to take the square root of each side. And so then we get c is equal to the square root of 52. So whichever way is best for you, either finding the area of each of these squares and then adding together and taking the square root, or using the Pythagorean theorem, either one of those is fine. See if you can figure out the red one. Okay, so whichever way you did it, whether you use the Pythagorean theorem or whether you use the squares, you should have gotten the square root of 20 for your side length. Okay, finding the distance from one point to the other. Again, basically what you're doing is you're just turning this into a right triangle. So you're taking this, you're turning it into a right triangle, and then you're finding your a squared plus b squared equals c squared again. So in this case, it doesn't matter which one is a and which one is b. We can let this side be a and this side be b. So a is 1, 2, 3, 4, 5. and B is 1, 2, 3, 4, 5, 6, 7, 8. Okay, and you can imagine that if there's a square over here, what the area of the square would be and the area of the square down here, and then add those together to get the area of the square up here. Using the Pythagorean theorem, we do 5 squared plus 8 squared equals c squared. 25 is 5 squared. 64 is 8 squared. And we're looking for c squared. When we add those two together, 25 plus 64 is 89. So that tells us the area of the square that would be on the hypotenuse. And remember, to go from the area to the side length, you just have to take the square root. So that's the last step for our Pythagorean theorem every single time, is to take the square root. So the length of the hypotenuse here would be square root of 89. All right, and then the last thing that we're going to talk about is determining whether 3 lengths make up a right triangle or not. So if you notice here, there's 3 things that we need to know about the hypotenuse. Whoops. Okay. Okay, number 1, it's the longest leg. I guess the longest side of the triangle. Okay, it is always represented with C. In the Pythagorean theorem. And the last thing is that it's always opposite the 90-degree angle. Okay, so if we look at each one of these sets right here, and this one is a little bit easier to see, but each one of these longest legs would be our C, okay? And then it doesn't matter, we can do A and B, A and B, A and B. We're just going to label these A and B, A and B, A and B, okay? So in order to determine whether or not these 3 side lengths would make up a right triangle, all we're going to do is we're going to take these 3 values and we're going to plug them into the Pythagorean theorem. So in this case, A is 3, B is 4, and C is 5. Okay, so when we square 3, that's 9. When we square 4, that's 16. So 9 plus 16 gives us 25. And over here, if we square 5, we get 25. So what we're looking for is we're looking at these 2 answers right here, okay? And so if this matches this, then the triangle is a right triangle, okay? Let's look at, we'll look at this one down here. Okay, so A is 4, B is 4, whoops, and C is 4. So when we square this 4 over here, we end up with a 16. If we square this 4, we get 16, and if we square this 4, we get 16. So 16 plus 16 is 32. So again, we're comparing this side over here to this side over here. Now 32 and 16 are not equal, so this means that this is not a right triangle, okay? So see if you can try these last 4, determine whether they're right triangles or not, and then pause it for a minute, and then when you're done, unpause it and the answers will be there for you. And I've got a couple more that I want you to try really quick. Okay, so on this last one, you should, well, here are the answers for the 4. Yes, no, no, no. All right, now if we look at this one here, we've got 8, 17, and 15. So remember we talked about the hypotenuse? The hypotenuse always has to be the longest leg. So if you look at these 3 pieces, this one, 17, would have to be C in this case. You can't just always go A, B, C. You always have to make sure that the one that's the longest is the one that's your hypotenuse. So you have to be really careful with this. And in this case, if you were to do this, you would get 8 squared plus 15 squared is equal to 17 squared, and they would both equal 289. And so yes, this one would be a Pythagorean triple. Okay, hopefully you're still doing well. If you have questions, let me know. I will send the assignment that goes with this. Make sure you read the instructions. And then I will post what we did on Thursday. It's basically another level problem practice. So hopefully I will get that done tonight. I won't be able to get it done right away, but I'll have it done up tonight. So anyway, good luck. Hope to see you soon. Take care.